Hello boys and girls, I'm afraid I'm not with you again. It's because I've broken my hand and today I'm getting a new pot on it. I'm hoping that the pot will be red because I support Liverpool Football Club. Anyway, let's get on with the lesson. Today we're going to try and think about how many switches are actually inside our computers. Remember that computers are made up of switches, and one switch, because computer people like silly names, is called a bit. One switch is called a bit. This stands for binary digit. Remember, a switch can be on or off, or 0 or 1. That's two symbols like binocular, bicycle. Binary is two digits. Binary, two numbers. 0 and 1, a binary digit. A bit is one switch. We group switches into groups of 8, called a byte. You'll have heard of that word before in other words like kilobyte and megabyte. And today we're going to have a look at what that actually means. So we group switches into groups of 8, called a byte. Remember, we counted using 8 switches, didn't we? There are the 8 switches: units, 2s, 4s, 8s, 16s, 32, 64 and 128s. That's 8 switches, each representing a different number. We group our bytes together into kilobytes. 1024 bytes is a kilobyte. Why 1024? Well, surely you'll say kilo means 1,000, like kilometre and kilogram, not 1024. Well, you'd be right in the normal world, but this is the world of computing. In computing, 1024 is the closest binary gets to 1000. Look. Units, 2s, 4s, 8s, 16s, 32s, 64, 128, 256, 512, 1024. So 1024 bytes is a kilobyte. 1024 kilobytes is a megabyte. 1024 megabytes is a gigabyte. 1024 gigabytes is a terabyte. That sounds like an awful lot of switches, but how do we calculate how many there really are? Well, what we do is we start with this diagram. I've written out bit, byte, kilobyte, megabyte, gigabyte and terabyte across the top, leaving gaps. And between each of the words I've put in how many of the thing on the left equals the thing on the right. So 8 bits is 1 byte. 1024 bytes is a kilobyte, 1024 kilobytes is a megabyte, 1024 megabytes is a gigabyte, 1024 gigabytes is a terabyte. Here's the question we'll solve then. How many bits are there in a megabyte? Remember, a bit is a switch. So how many switches make up a megabyte? What we do is this. We draw a wiggly line under the two words that were involved in our question, bit and megabyte. There they are, the two wiggly lines. How many bits in a megabyte? Then we multiply together all the numbers between the wiggly lines. That would be 8 times 1024 times 1024. When you do that on a calculator, because you'll do that on a calculator surely, that comes to 8,388,608 bits, or 8.5 million switches. So if you find something that's 1 megabyte large, that's 8.5 million switches. That's an awful lot of switches. Have a look at your phone. Mine is old. It only has 16 gigabytes of storage. Can you see I've worked out the sum that I need to do? I've put a wiggly line under bit and a wiggly line under gigabyte, and then multiplied all the numbers in between. I've also put in a 16 because if I just multiply 8, 1024, 1024 and 1024, I find how many switches is in 1 gigabyte. But I've got 16 gigabytes. See if you can work out how many switches that is. When you've done that, you need to make a poster to remind yourself of the numbers we've talked about today. You can do that in the cloud or in PowerPoint. Here is my example to help you. I'm sure your supply teacher or cover teacher will pause this on this screen so you can see the sort of thing I'm looking for to help you remember. I've given each of the measures of switches, bits, bytes, kilobytes, megabytes, gigabytes and terabytes, an increasingly scary monster to help me remember. Don't forget to save your work, especially if you're using PowerPoint. And you can call it How Many Switches. Have a lovely lesson, and I'll see you around the school, and I'll be in your lesson next week.